What's up guys, databases! Today I will talk a lot about them. Selecting the right database is sometimes the single most critical decision in system design. Furthermore, the long-term consequences may remain hidden for years. Today I provide a short summary about my experiences with different database technologies and how to pick up the right one based on your application. So, many years ago, I conducted a year-long POC for a new data warehouse program. We ended up with selecting a distributed, horizontally scalable MPP database, the right one for the job. However, thanks to some reorganization, a new management came and have overridden the old decision, claiming we were old-fashioned. And we must have selected a Hadoop-based solution for our scope, which had zero piece of unstructured data. In the first year, everything was fine. The second year was a nightmare of regular memory and compatibility issues. Let me help you avoid a similar situation, focusing on the 6 areas of requirements to ensure selecting the appropriate database for your use case. Number 1. Data requirements. What types of data will be stored? Structured, semi-structured, unstructured. What is the expected volume of data? Gigabytes, terabytes, petabytes. What are the data access patterns? Is it read heavy or write heavy? What are the data consistency and integrity requirements? If the data is structured and requires strong data integrity and consistency, relational database management systems such as MySQL, PostgreSQL, or Oracle are good choices. If the data is semi-structured or unstructured and requires flexibility, document database such as MongoDB or Couchbase are perfect choices. Number 2. Performance and scalability needs. How many concurrent users or applications will access the database? What are the expected response time and throughput requirements? Is horizontal scalability, adding more servers and nodes, or vertical scalability, upgrading the hardware, more important? Does the system need to handle real-time or high-velocity data? If the system requires high scalability, high availability, and can handle unstructured or semi-structured data, then NoSQL databases like Cassandra, HBase, or Amazon DynamoDB are perfect choices. If the system deals with complex relationships and interconnected data, graph databases such as Neo4j or Amazon Neptune are potentially good choices. Number 3. Data model and schema requirements. Is the data highly structured or does it have a flexible evolving schema? Does the project require complex relationships or graph-like data structures? Are transactions and ACID compliance necessary for the data integrity? Lot of buzzwords. If the data has a fixed schema and requires transactions and ACID compliance, RDBMS such as MySQL, PostgreSQL, or Oracle are good choices. If the data has a flexible or evolving schema, document databases such as MongoDB or Couchbase are the right choices. Number 4. Data connectivity and dependency. How strongly is your data connected with each other? Can you process them row by row, or column by column, or maybe file by file? The more independent is your data points, no need to combine them, join them, the better scalability you can achieve, and the less complex distributed solution you need. Image files, for example, can be processed easily one by one, independently from each other in separate servers or nodes. So, you don't need an advanced, sophisticated data layer. A simple HDFS or blob stores are ideal candidates. If your datasets are strongly connected with each other, need to be joined for processing, then consider RDBMS, such as MySQL, PostgreSQL, or Oracle, or graph databases such as Neo4j or Amazon Neptune. Number 5. Availability and fault tolerance. We are almost there. Does the system require high availability and fault tolerance? How critical is the system's uptime? Are application backup and disaster recovery mechanisms required? If yes, NoSQL databases like Cassandra, MongoDB, or DynamoDB are designed for distributed architectures and fault tolerance. Or, generally speaking, cloud-based databases have built-in replications and backup mechanisms. Number 6. Security and compliance. This is the last one. Are there specific security measures needed, such as encryption or access controls? Does the project need to comply with any data protection regulations or industry standards? If so, traditional RDBMS like PostgreSQL, Oracle, MySQL often provide extensive security features. In my upcoming video, I will demonstrate the process of selecting the suitable database for 3 specific types of applications using these areas of requirements we uncovered together. See you there.